So hi everyone, welcome to the Student brand. So this is our Shiva sir. I hope it is very clear. So myopia, 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 myopia. Near distance we can see, far distance we can see. Myopia, 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 myopia. Myopia, 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 myopia. Near distance we can see, far distance we can see. Myopia, 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 myopia. For that correction we are using, bro. What, bro? For that correction we are using concave lens, concave lens, concave lens, concave lens. Myopia, 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 myopia. Near distance we can see, far distance we can see. Hypermetropia, 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 hypermetropia. Far distance we can see, near distance we can see. Hypermetropia, hypermetropia. For the correction, we are using convex lens, convex lens, convex lens, convex lens. Hypermetropia, hypermetropia. Convex lens, convex lens, hypermetropia, convex lens, hypermetropia, convex lens. New Cartesian sign convention, new Cartesian sign convention, all distance measure from the distance positive along the instant trace, distance negative opposite to instant trace. Distance are positive along the incident race. Distance are negative opposite to incident race. Distance are positive above the principal axis. Distance are negative below the principal axis. Cartesian sign convention. Cartesian sign convention. All distance are made from the pole. Distance are positive along the incident race. Distance are negative opposite to incident race. Distance are positive along the incident race. Distance are negative opposite to incident race. Distance are positive above the principal axis. Distance are negative below the principal axis. Cartesian sign convention. Cartesian sign convention. All distance measure from the pole. Distance are positive along the instant race. Distance are negative opposite to instant race. Distance are positive above the principal axis. The negative below the principal axis. New Cartesian sign convention. New Cartesian sign convention. New Cartesian sign convention. New Cartesian sign convention. Okay, so everybody, welcome to the class. Welcome to the class. Welcome to the class. So, this is your Shiva sir. Today, the topic is light reflection and refraction. Light reflection, refraction. Light reflection, refraction. So now I am considering plane mirror. Now I am taking the plane mirror, right? So I am considering the plane mirror. So a highly polished smooth surface. A highly polished smooth surface is called plane mirror. So I'm considering here light reflection and refraction. Light reflection, reflection and refraction, refraction. CBSE grade 10 physics. CBSE grade 10 physics. So I am considering now. So I'm taking the plane mirror. I'm taking the plane mirror. So incident light is falling on it. Incident light is falling on it. Okay. So I'm taking the plane mirror. So a highly polished smooth surface. I'm taking this highly polished smooth surface. So incident light rays are falling. So here one side is reflecting surface, another side is coated one. One side is reflecting surface, another side is coated one. So I'm considering this is a plane mirror. One side is reflecting surface, another side is coated one. Okay. So incident rays, this is incident ray, this is incident ray, light is incidenting on it. So this will be reflected ray, reflected ray. So I'm taking this a dotted line, dotted line. This is the normal line. So incident ray, reflected ray, normal line. 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 Incident ray, so the angle between incident ray and normal line is called angle of incident. Angle between reflected ray and normal line is called angle of reflection. So angle between incident ray and normal line is called angle of incident. Angle between reflected ray and normal line is called angle of reflection. So we are drawing the dotted lines. So we are drawing the dotted lines like this. So here the angle between this undeviated line, this is the undeviated line. Angle between reflected and undeviated line is called angle of deviation. Angle of deviation. Okay. So once again here I am considering. So incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line, and undeviated line are initial direction of the incident ray. So the angle between incident ray and normal line is called angle of incident. Angle between reflected and normal line is called angle of reflection. And angle between reflected and undeviated lines or undeviated line or initial direction of the incident ray is called angle of deviation. Angle of deviation. From laws of reflection, we can see from laws of reflection, laws of reflection, from laws of reflection, angle of incident equal to, so I'm first one, angle of incident incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line lies on the same plane. Lies on the same plane. What is the angle of deviation? Angle between so undeviated line and reflected ray, that is called angle of deviation. So the angle between, so here angle between incident ray and normal line is called angle of incident. Angle between reflected normal line is called angle of reflection. Angle between reflected and undeviated line is called angle of deviation. Laws of reflection. So coming to the laws of reflection, laws of reflection, laws of reflection. So incident ray, reflected ray, normal line lies on the same plane. Laws of reflection are nothing but incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. So incident ray, reflected ray, so incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. So angle of second one is angle of incident equal to, second one angle of incident equal to angle of reflection. Angle of incident equal to angle of reflection. So here I am considering, so incident ray, reflected ray, normal line lies on the same plane. First one, incident ray, reflected ray, normal line lies on the same plane. Coming to the second one, angle of incident equal to angle of reflection. 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 Okay, so these are the two laws of reflection. These are the two laws of reflection. These are the two laws of reflection. So that is about okay. So angle of incident, angle of reflection. So now you are taking the linear angle. Now you are taking the linear angle is 180 degrees. Linear angle is 180 degrees. So angle of incidence, see in this linear angle. So to normally if you are saying linear angle is 180 degrees. Linear angle is 180 degrees. So in this linear angle, we can observe angle of incident plus angle of reflection plus angle of deviation, three are combined. Angle of incident plus angle of reflection, angle of incident plus angle of reflection plus angle of deviation. So these three are combined. These three are combined. So then we can consider angle of incident plus angle of reflection plus angle of deviation. So three are combined. That is nothing but equal to 180. Equal to 180. So now you are considering here. So angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Equal to 180 degrees. So now you are considering. So the same thing will be written in this format. You can check once. So you can check once. Okay, I will write in this format. That is about with the help of angle of incidence equal angle of reflection. So if you are taking 180 degrees, angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. 180 degree. From loss of reflection, so we can write angle in the place of angle of reflection. Can I write angle of incident? In the place of angle of reflection, can I write angle of incident? In the place of angle of reflection, can I write angle of incident? So now you substitute angle of incident. Now I am substituting angle of incident plus angle of incident plus angle of deviation equal to 180 degrees. So now the angle of deviation equal to 180 minus 2 angle of incidence. 180 minus 2 angle of incidence. See, you are writing in the place of angle of reflection. So I am writing angle of incident. In the place of angle of reflection, I wrote angle of incidence. That's why the formula is angle of deviation equal to 180 minus 2 angle of incidence. 180 minus 2 angle of incidence. So in that place, instead of angle of reflection, if I place angle of incident with angle of reflection, angle of incident with angle of reflection, the formula becomes angle of reflection plus angle of deviation equal to 180 degrees. So angle of deviation equal to 180 minus 2 angle of reflection. 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 So angle of deviation equal to 180 minus 2 angle of reflection. So here, as I said, in the place of angle of incident, I am substituting angle of reflection. So that's why we got the formula angle of deviation equal to 180 minus 2 angle of reflection. So the same thing you can observe here. So in the place of angle of reflection, I'm writing angle of incident. Then the formula becomes angle of deviation equal to 180 minus 2 angle of incident. So angle of deviation equal to 180 minus 2 angle of incidence. So like that we can write. So this is about angle of deviation. This is about angle of deviation. So this is about angle of deviation. Next we are going to the next one. That is about angle of deviation completed. Regular reflection and irregular reflection I will explain. Just check once. Regular reflection and irregular reflection. Regular and irregular. So when it will be regular and irregular. So related to reflection, loss of reflection, what type of questions they will ask? Related to this formula, what type of questions they will ask, we'll discuss. So normally if you are taking, okay, if the light ray incident along the normal line, and one more point here you can observe, okay, so now the light is incidenting, see, one more point also I will explain here. One more point, very very important point I will explain. That is, if the light is incidenting on the plane mirror, okay, if the light ray incident on the plane mirror, okay, so what happens if you are taking like this? I am considering like this. If the light is passing along the normal line, so like this, if you am taking, if the light ray passes along the normal line, okay. So in this case, what is the angle of incidence? What is the angle of reflection, and what is the angle of deviation? So in this case, what is the angle of incidence? What is the angle of reflection? And what is the angle of deviation? What is the angle of incident? What is the angle of reflection? And angle of deviation. Now you are considering, if the light ray passing along the normal line, so angle of incidence is 0, angle of reflection also 0, angle of deviation equal to 180 degrees. So this angle I am taking, that's why it is 180 degrees. Angle of deviation equal to 180 degrees. Angle of deviation equal to 180 degrees. So only in this case we'll get angle of deviation equal to 180 degrees. Suppose if the light ray incident on the plane mirror, so with angle 60 degrees I'm taking. Okay, 60 degrees. So the light ray incidenting at the plane mirror. So with the angle of 60 degrees I'm taking here. Like this, the plane mirror, the light ray incidenting like this. So this is the incident ray. The angle of incident is okay. So I'm taking here. So this is a reflected ray, incident ray, reflected ray. I'm taking this a normal line. So the angle between this one is suppose I'm taking 60 degrees. What is the angle of deviation? So sorry, not angle of deviation. Glancing angle of incidence. What is the glancing angle of incidence? How to find out? Anyway, angle of reflection we can get to know it. Angle of reflection is, so angle of incident equal to angle of reflection. Angle of incident equal to angle of reflection. We know that one. Angle of incident equal to angle of reflection. Angle of incident equal to angle of reflection. So angle of incident equal to angle of reflection. हिंदी थोड़ा थोड़ा आता, पूरा नहीं आता, थोड़ा थोड़ा अच्छा है, लाइक ठीक है, मालूम, थोड़ा थोड़ा, तो थोड़ा थोड़ा हिंदी, बड़ा बड़ा नहीं आता, तो प्लीज एडजस्ट करो. So I'm taking angle of incident is 60 degrees. Here also I'm taking angle of incident is angle of reflection is, angle of incident is 60 degrees. Angle of reflection also 60 degrees. Angle of reflection also 60 degrees I'm taking here. Okay, so this also I'm taking. But they're asking about a glancing angle. Glancing angle of incident is nothing but the angle between incident ray and plane surface. The angle between, so this question they will ask. The angle between incident ray and plane surface. This is the incident ray and this is the plane surface. Incident ray and plane surface. Incident ray and plane surface. Incident ray and plane surface. Okay. So this angle is called glancing angle of incident. Normally this is totally is 90 degrees, right? Total is 90 degrees. So 90 minus 60 is 30 degrees. 90 minus 60 is 30 degrees. So the glancing angle of incident is 30 degrees. Glancing angle of incident. So glancing angle of incident will be taken between incident ray and plane surface. Between incident ray and plane surface. 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 The angle between incident ray and plane surface is called, the angle between incident ray and plane surface is called, the angle between incident ray and plane surface is called, the angle between incident ray and plane surface is called glancing angle of incidence. Whereas glancing angle of reflection, if you are taking the angle between reflected and plane surface, angle between reflected and plane surface, angle between reflected and plane surface is called glancing angle of reflection. Glancing. So these questions they will ask. This question generally we follow angle of incident and angle of reflection. So and the angle of deviation we will solve the angle of deviation formula. But we will miss this one. That is a glancing angle of incident. Glancing angle of incident will miss because this is very very important. Glancing angle of incident is very very important. So if the paper, if they are asking paper little more twist manner, little more logical manner, little more twist manner. So they will ask this question. And glancing angle of incident and glancing angle of reflection also. Glancing angle of incident and glancing angle of reflection. Very, 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 very important. Okay. So angle of incident, if you are taking 60, angle of reflection also 60 degrees. Angle of incident is 60 degrees. Angle of reflection also 60 degrees. Okay. So I am considering now. Okay, so hi everyone, welcome to the class. Now glancing angle of incident is 30. Glancing angle of incident is 30. Now, so one more condition I'm taking. So the light which is reflecting back on the where a reflection taking place here. So one more point. So where the reflection is taking place, this surface is called a reflector. The surface is called a reflector. The surface is called a reflector. So where the reflection is taking place, that is called a reflector, because so it is reflecting the light ray. So it is a reflecting the light ray. The surface which is reflecting the light ray is called a reflector. So the surface which is reflecting the surface which is reflecting, or reflection is taking place on the surface is called a reflector. Okay, so I hope it is very clear to you all. Next one we are going to the next one. Next one is so reflection over regular reflection and irregular reflection. I'll explain regular reflection and irregular reflection. So I'm considering here, I'm taking the plane surface here. So this is the smooth surface. This is a smooth surface. Smooth surface. I'm taking this a smooth surface. Smooth surface. Smooth surface. Smooth surface. Smooth surface is plane mirror. 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 So when the light ray incident on it, okay. So this will see, these are the incident light rays. These incident light rays are parallel to each other. Whatever the light rays are incidenting on it, okay. So these incident light rays are parallel to each other. The light rays which are incidenting on it, those light rays are parallel to each other. Okay, all light rays are parallel to each other. If the reflector light rays also parallel, reflector smooth surface, highly polished surface is called smooth surface. Smooth surface is plane mirror. Okay, plane mirror. So I'm considering these are the reflector light rays. These are the reflector light rays I'm taking. These are the reflector light rays. So if the reflector light rays are parallel to each other, if the reflector light rays are parallel to each other, this type of reflection is called regular reflection. So incident beam is parallel, reflected beam also parallel. 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 This type of reflection is called regular reflection. Regular reflection takes place on smooth surface. 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 Smooth surface, and also regular reflection takes place on still water and plane mirror, still water and plane mirror, still water and plane mirror. Okay, so this I am taking regular reflection. So incident beam is parallel, reflector light rays also parallel. Conditions. If you are taking condition, incident beam is parallel, reflector light rays also parallel. So this type of reflection is called regular reflection. Regular reflection takes place on either one is still water, another one is plane surface, highly polished smooth surface. Okay, so next one we are going to the, this is the regular reflection. Coming to irregular reflection, I am taking the irregular reflection like this. Irregular reflection. So irregular reflection I am taking here. Okay, so like this I am considering. So incident light rays are parallel to each other. So I am taking, these are the incident light rays. 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 Okay, incident light rays are parallel to each other. Incident light rays are parallel to each other. If the reflector light rays also, if the reflector light rays are not parallel to each other, incident light rays are parallel, but reflector light rays are not parallel to each other. So reflector light rays are not parallel to each other. Incident light rays are parallel, but reflector light rays are not parallel to each other. So this type of reflection is called irregular reflection. This type of reflection is called irregular reflection. So I'm considering here like this. So this reflector light rays are not parallel to each other. Then what happens? So those light rays will move in different direction. Those light rays will move in different direction like this. Okay, so this is about irregular reflection. Irregular reflection or diffused reflection. Irregular reflection or diffused reflection. Irregular reflection or diffused reflection. So irregular reflection or diffused reflection. So whenever light ray incidenting on it, so when you are taking, when the light ray incident on it, the reflector light rays are not parallel to each other. Okay. So here in this case, irregular reflection takes place. Irregular reflection takes place on wall. wall you can take, book you can take. Okay, so on book, so there is one question related to regular reflection and irregular reflection. A wall reflect the light rays, and a wall reflect the light rays, and a plane mirror reflect the light rays. So what is the difference? A wall reflect the light rays, and at the same time a plane mirror also reflect the light ray. What is the difference? Wall reflect, so light rays will move in different direction. Light rays will move in different direction. Irregular reflection takes place on wall. So plane mirror, if you are taking on plane mirror, regular reflection takes place on plane mirror. Regular reflection takes place on plane mirror. Regular reflection takes place on wall. Irregular reflection takes place on wall. Irregular reflection takes place on wall. Irregular reflection takes place on plane mirror. Regular reflection takes place on cinema screen. Irregular reflection takes place, and also we can take wall, cinema screen, we can take still water we can consider. Still water, regular reflection. Plane mirror, regular reflection. Cinema screen, wall, these are the irregular reflection. So this type of questions they will ask in the exam. I hope it is very clear. So this is about regular reflection, and here it is irregular reflection. Regular reflection takes place on smooth surface. Irregular reflection takes place on rough surface. Regular reflection takes place on smooth surface. Irregular reflection takes place on rough surface. Irregular reflection takes place on rough surface. So related to this one, so few questions are there. We will discuss those questions. So those are okay. Last here I'm considering related to regular reflection and irregular reflection. Yes, so cardboard, what type of reflection takes place on cardboard? On cardboard, irregular reflection takes place. On still water, regular reflection takes place. I already asked one question. Okay, so that is about a wall reflect light rays. A wall reflect light, and mirror also reflect light. What is the difference in the way reflect the light rays? Wall reflect irregular reflection. Plane mirror reflect regular reflection, right? So what is the radius of curvature of the plane mirror? Radius of curvature. So these type of questions they will ask. So we'll discuss these questions. Okay. Now I am considering here. Here the question is, so what is the radius of curvature of the plane mirror? Radius of curvature of the plane mirror is infinity. So point number 1, radius of curvature of the plane mirror is infinity. So focal length is automatically infinity, r equal to 2f. So what is the power of plane mirror? Power of plane mirror is 0. So P equal to 1 by f. P equal to 1 by f, you are taking P equal to 1 by f, f equal to infinity. So f is nothing but 1 by 0. 1 by 0 I am considering. So P equal to 1 by 0. If it is goes upward direction, 1 by 1 into 0. So P equal to 0. So power of plane mirror is 0. Okay. So I hope it is very clear to you all. So this is about power of plane mirror. What type of reflection of light leads to the formation of images? So reflection of light is what type of regular reflection? Regular reflection of light leads to the leads to the formation of images. Regular reflection. And what is the value of speed of light in free space? Speed of light in okay, so 3 into 10 power 8 meter per second. 3 into 10 power 8 meter per second. So speed of light in vacuum or free space is 3 into 10 power 8 meter per second. So very important questions. This question. Okay, so keep in mind. Anyway, values are there. Next one. So we are going to the plane mirror, cinema screen, Yes. Define the reflection of light. Define the reflection of light. The bouncing back of the light from the reflecting surface. The bouncing back of the light from the reflecting surface is called the bouncing back of the light from the reflecting surface is called reflection of light. State the laws of reflection of light. What are the laws of reflection of light? So incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. So state laws of reflection. Laws of incident ray, reflected ray, normal lines lies on the same plane. Lies on the same plane. And angle of incident equal to angle of reflection. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. So next one, we will go to the next one. Next one, we are going to the next point. Okay, I hope it is very clear. This only these points only related to. What are the uses of plane mirror? What are the uses of plane mirror? They are used as a looking glass. They are used in construction of periscope, kaleidoscope, and they are also used in solar cookers. Solar cookers. Okay. So next one, I will explain regular reflection after that. So we'll go to the plane image formations. What type of image will be there? So real image and virtual image will discuss. Real image and virtual images. Real image and virtual image will discuss. Okay, so when the light is incidenting on it, so I'm taking here. So if the light ray incident on it, I'm considering here, this is a plane mirror. I'm taking the plane mirror here. This is a plane mirror. Okay. So this is the normal line. So normal line I'm taking, normal line I'm considering. So from here, I'm taking the object. That is the object. Okay. So that is the object I'm taking. So once again, I'll draw. So here I'm considering the plane mirror. This is a plane mirror. I'm taking here. Plane mirror. Like this, I'm taking this. This is an principal axis. So plane mirror, I'm taking the plane mirror and principal axis. Plane mirror. So plane mirror. Okay. So this is the plane mirror I'm taking and principal axis. When the object is placed here, I'm placing the object here. How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. Minimum 2 light rays. 2 light rays are required. 2 light rays. How many light rays are required to form the image of the object? Minimum. How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object, right? Yes or no? So now I'm taking here from this point, I'm taking 2 light rays. Okay, you can observe here. I'm taking 2 light rays. Okay, so I'm considering 2 light rays. 1 light ray I'm taking here. So this is 1 light ray, and one more light ray. So those are reflected back like this, and here also reflected back. Those are reflected back. So if you are extending those light rays, those light rays are meeting at one point. So here I'm considering, these are the, so if you observe carefully here, okay, so I'm taking, these are the reflect, this is incident ray, this one is the reflected ray, right? So incident ray, reflected ray, incident ray, reflected ray, incident ray, reflected ray. So incident ray, this is incident ray, reflected ray. Okay. So I'm considering here, this is I1, R1, I2, R2. If you are extending those light rays, those light rays are meeting at one point. Those light rays, if you are extending this light ray, these light rays are meeting at one point. Okay, so here is image is forming. This is a real object. This is the virtual image. Real object and virtual image. So one more case I'll take. So you can draw. So you can take one more observation. So one more diagram I'm considering. Here. So I'm taking one more diagram like this. Okay. So this is the principal axis. I'm taking the light rays are coming from the certain point. If you are taking this, light rays are coming after reflection. Those light rays are meeting at one point. So here, if you are extending these incident rays, Those incident rays are meeting at one point. Those incident rays are meeting at one point. So here is a real image is forming, real image. This is the virtual object, virtual object. Okay. So here if you are taking, here you can observe this condition. If you are observing this condition, if you observe this condition here, okay. So this from this point light rays are coming, from this point light rays are coming, from this point light rays are coming. After incidenting those light rays, so those light rays are reflected. So if you are extending this reflector light rays, those reflector light rays are meeting at one point. So this is reflected ray, this is reflected ray. So these reflector light rays are meeting at one point. Extended reflector light rays. So here directly reflector light rays are not meeting. Directly reflector light rays are not meeting. We are extending those reflector light rays. We are extending those reflector light rays. Extended reflector light rays. Extended reflector light rays. Extended reflector light rays are meeting at one point. Their image is forming. That is virtual image. Extended reflector light rays are meeting at one point. So their image will form. Their image will form. That type of image is called virtual image. So and one more thing here you can observe. Here you can observe. This is incident ray. This is incident ray. Suppose if you take, I am considering this is incident ray. Incident ray I1. This is the R1, I2, I2 and R2. Okay. So here I1 incident rays are coming from infinity. Incident rays are coming from infinity. After reflection, what is speed of light? 3 into 10 power 8 meter per second in free space. In free space or air we can take, or air or vacuum also we can take. Speed of light in vacuum. Speed of light in vacuum or air. 3 into 10 power 8 meter per second. Okay. So here if you are taking, these are the incident rays. Incident rays are coming from one point. Incident rays are coming from one point. Okay. So these incident rays are coming from this point. After reflection, those light rays are meeting at one point. After reflection, those light rays are meeting at one point. So what type of light rays? We are extending these light rays. So directly reflector light rays are not meeting. These light rays are extended reflector light rays. These light rays are extended reflector light rays. Extended reflector light rays are meeting. That is called virtual image. Extended reflector light rays are meeting. That is called virtual image. So this is the incident ray, this is incident ray. After reflection, those light rays are meeting at one point. So incident ray. After reflection, those light rays are meeting at one point. This is the real image. Real image. So if you are extending these incident rays, those incident rays are meeting at one point. So here we can observe one thing. Here you can observe one thing. Here you can observe one thing. Here you can observe one thing. So we are extending the incident rays. Here we are extending the incident rays. Here we are extending the incident rays. Here we are extending the incident rays. Extending incident light rays are meeting at one point. Extending incident light rays are meeting at one point. Their image is forming. That is a virtual image. But their object is forming. That is a virtual object. Virtual object. So by once again I will conclude these points. The conclusion is, so here is a real object, here is virtual object, here is virtual image, here is a real image. So what is the difference? Here image is, here is real object is real, here is virtual object you are selling. So here is real object, here is virtual object, here you are taking virtual image, here we are saying real image. So how it is possible? Here the light rays are directly meeting. If the light rays are directly meeting, if the light rays directly meet, if the light rays are directly meeting, then that type of image is directly. If the light rays are meeting, that is a real image. If the light rays are directly meeting, that is a real image. We are extending the reflector light rays. Extending the reflector light ray. If you are extending the reflector light rays, these reflector light rays we are extending. Their image is forming. Reflector light rays, extension of reflector light rays. So here we can conclude that from this point, we can conclude one thing. If extended incident rays or extended reflector light rays, either extended incident rays or extended reflector light rays, whether it is extended reflector light rays or whether it is extended incident rays, that is virtual, whether it is object or image. If it is light incident light rays, virtual object. If it is reflector light rays, extending reflector light rays, that is a virtual image. So it depends on extension. If you are extending the incident rays, virtual object, extending the incident rays, virtual object, extending the reflector light rays, virtual image, extending the incident light rays, virtual object, extending the reflector light rays, virtual image. Directly reflector light rays are coming from the point, real object. Reflector light rays are meeting directly. Reflector light rays are meeting directly. So yes, nice. Reflector light rays are meeting directly. Reflector light rays are meeting directly. Reflector light rays are meeting directly. That is called real image. That is called real image. We can conclude that. We can conclude one thing. We can conclude one thing. So that is, we can conclude one thing. Okay. So if the object is real, image, object and image. So object is real, image is virtual. Object is virtual, image is real. Image is real. So this is very very important, very very important concept. Object is real, image is virtual. Object is real, image is virtual. So very 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 important this question. So make sure that you are learning this point very 100%. So the based on this one question will come. That type of important it is. That type of important it is. Very 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 important. Very important. Very important. Now, so you can see object is real, image is virtual. Object is virtual, image is real. Object is real, image is virtual. Object is virtual, image is real. So very very important, very very important, very very important. So make sure that you are learning this one. We are learning this one. Next one, next one, next one, next one. Next one we are going to the one more point. One more point. So one more point is, so next one we are going to the one more point. One more point, that is, so what is the characteristics of the image formed by the plane mirror, or what is the nature of the image formed by the plane mirror? We'll discuss characteristics of the image formed by the plane mirror, or nature of the image formed by the plane mirror. We will discuss now. We'll discuss now. Okay. So now you are considering. Now you are considering one more. Okay. So when the object is, if you are taking, when the object you are taking. Okay. So here consider. If the object is real, so I'm taking here, so this is a plane mirror, this is a plane mirror, this is a plane mirror I'm taking, right? So if you are considering the principal axis, now I am taking here, okay, like this. So object is placed here. This is the object. How many light rays are required to form the image of the object? As I said, minimum 2 light rays are required. So before I said how many light rays are required to form the image of the object, minimum 2 light rays are required to form the image of the object. Minimum 2 light rays are required to form the image of the object. So minimum 2 light rays. So I am considering 1 light ray. So here you can take 1 light ray I am taking here. So this is 1 light ray. This is 1 light ray. So normally if you are taking the plane mirror, if you are taking this a plane mirror, if the light ray incident along the normal line, what happens? So it retraces its original path. So if the light ray is passing along the normal line, so the reflector light rays moves in the same direction. Retrace its original path. If the light ray incident along the normal line, so the reflected ray moves along the same line. Okay. So now I am considering here. So here also 1 light ray I am taking like this. It will be reflected back. One more light ray I am taking here. So after incidenting, this will be reflected. So this is a reflected phenomena, right? So it is reflected phenomena. So 1 light ray incident on it. 1 light ray I am incidenting on it. Okay. So I am taking here. This is the incident ray. So this will be the reflected light ray. So if it is incidenting along the normal, it reflected back. I am taking here one more. So this will be reflected back. Okay. So if you are extending this light ray, I said before only I said before only. Okay. So if you are extending light ray, if the extending light rays meet at one point, if the extending light rays meet at one point, if the extending light rays meet at one point, if the extending light rays meet at one point, if the extending light rays meet at one point, their image will form. Their image will form. Their image will form. Their image will form. That is the their image will form. That is a virtual image. That is a virtual image. So I'm taking here. I'm taking here. I'm considering here. I'm considering here. Okay. So if you are extending this light rays, if you are extending this light rays, and I am considering here also, we are extending this here. We are extending here. So the image will form here. The image will form here. So what type of image will form? Virtual erect and same size. 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 Okay. So I'm considering this is the AB, and this is the A dash and B dash. So AB, A dash and B dash. AB, A dash and B dash. Right? Yes. Now you are considering here. Okay. So here the distance between object to mirror is called object distance. The distance between object to mirror is called object distance. The distance between mirror to image is called image distance, object distance and image distance. Okay. So the distance between object to mirror, the distance between object to mirror is called object distance. Distance between mirror to image is called image distance. Distance between object to mirror. Distance between object to mirror is called object distance. Distance between image to mirror. Image to mirror. So this is the image and mirror. This is the image and mirror. The middle one is the mirror. So the middle one is the mirror. Okay. So I'll draw here. So you can see this is the mirror. I'm taking this the mirror. Okay. This is the object and this is the image. Okay. The distance between object to mirror is called object distance. The distance between mirror to image is called image distance. So once again, the distance between object to mirror is called object distance. The distance between mirror to image is called image distance. Distance between object to mirror is called object distance. Distance between image to mirror is called image distance. Okay. So here I'm considering. So in the previous case, I explained one thing. In the previous class, I explained one thing. That is first point is object is real, image is virtual, object is virtual, image is real. So in the previous case I explained, if it is object is real, image is virtual. If it is object is real, image is virtual. Object is virtual, image is real. Object is real, image is virtual. Object is virtual, image is real. So vice versa. One it if you are taking object is real, image is virtual. Object is virtual, image is real. Vice versa we are taking. Vice versa we are considering. Okay. So now we are going to the next one. Next one here, object distance is equal to image distance. 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 And the next point if you are taking third one you are taking. So height of the object is equal to height of the image. So once again, height object distance is equal to image distance. Object distance is equal to image distance. Object distance is equal to image distance. Height of the object equal to height of the image. Height of the object equal to height of the image. And second one, if you are third, height of the object equal to height of the image. And fourth one, it also shows lateral inversion. Lateral inversion. It also shows lateral inversion. Lateral inversion. Lateral inversion is nothing but the phenomena of converting of right side of the object appears to be left side of the image. Right side of the object appears to be left side of the image. The phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. Best example, if you stand in front of the mirror, so what happens? your right side of the object appears to be left side of the image. Your left side of the object appears to be right side of the image. So once again, so if you are standing in front of the mirror, if you stand in front of the mirror, your right side of the object appears to be left side of the image. Your left side of the object appears to be right side of the image. So this mirror image is called a lateral inversion. Best example, you can see the ambulance on the road. So the letters written on the ambulance will be in lateral inversion. So when you see in the mirror, it appears proper. Best example, when you are standing in front of the mirror, if you are standing in front of the mirror and you lift your right hand, it appears in the left side. If you lift your left hand, it appears in the right side. Same phenomena. So one example I'll give. So from from A to Z, which letter does not show lateral inversion? From A to Z, which letter does not show lateral inversion? So O does not show. Okay, capital letters I'm telling, capital letters. So from A to Z, which letter does not show lateral inversion? Capital letters, O does not show. Okay, remaining letters you can type. You can type if you know which letter does not show lateral inversion. So question is, in the plane from A to Z, from A to Z, so which letter does not show lateral inversion? Capital letters I'm telling, which letter does not show lateral inversion? If you know, you can comment, which letter does not show lateral inversion in from A to Z. From A to Z, capital letters. Okay, so capital letters. So that's enough like a lateral inversion. And here one more thing, this is very important. So nature of the image formed by the plane mirror, nature of the image formed by the plane mirror, nature of the image formed by the plane mirror. So like object is real, image is virtual, object is virtual, image is real, object distance is equal to image distance, height of the object equal to height of the image, and also it shows the lateral inversion, and also it shows the lateral inversion, and also it shows the lateral inversion. Lateral inversion is nothing but the phenomena of converting of the right side of the object appears to be left side of the image, left side of the object appears to be right side of the image, right side of the object appears to be left side of the image, left side of the object appears to be right side of the image. So this mirror conversion is called, mirror image is called lateral inversion. So I hope it is very clear to you all. So this is about plane mirror, related to plane mirror. So related to plane mirror, if any questions are there, we'll discuss now. Okay. So related to plane mirror. Okay, so wall reflect. Under what conditions? So here is one question. Under what conditions in an arrangement of two plane mirrors? Under what conditions? The question is very important. This question they ask in the, okay, so in your slip test, unit test, these questions they will ask, very important questions. Under what conditions? The question is, so under what condition incident ray, reflected ray, so incident ray, reflected light rays both are parallel to each other. So that is a question. Okay. So now we will see. Under what conditions? So here consider. So the question is, under what conditions in an arrangement of two plane mirrors, incident ray and reflected ray will always be parallel to each other? Whatever may be angle of incident, show the same with the help of diagram. They are asking under what condition incident ray and reflected ray always be parallel. So I'm considering here, I'm taking this one plane mirror, so I placed here, and one more plane mirror I'm taking here, okay. So one more plane mirror I'm considering like this. This is one more plane mirror. So when the light ray incidenting on it, like this, incident ray, this is the reflected light ray, and I'm considering this this is also reflected light ray. So I'm taking this normal line. Okay, so these two become parallel to each other. Under what condition they are saying, right? Under what conditions incident ray, reflected ray, normal incident ray and reflected ray parallel to each other. So what are the angle of incident? So we are not talking about angle of incident. We are talking about, okay. So this is the reflected light ray. So reflected light ray like this. Okay. So this is the normal line. And this is the normal line. So here is angle of incidence, angle of reflection. This is the angle of incident, angle of reflection. So this is incident ray, incident ray. So incident ray, and this one is the reflected light ray, reflected ray, reflected, reflected ray. Incident ray and reflected light ray. So reflected ray. Okay. So these two are parallel to each other. These two are parallel to each other. Okay. So like this we are considering. Like this we are considering. Okay. So incident ray, reflected ray parallel to each other only when, so this condition, if the two plane mirrors placed at right angles to each other. So two plane mirrors placed at right angle to each other. Two plane mirrors placed at right angle to each other. So we'll get it. So what are the uses of plane mirror? So uses of plane mirror. They are used as a looking glass. What are the uses of plane mirror? So uses of plane mirror they are asking. They are used for looking glass. They are used in construction of periscope and kaleidoscope. So plane mirror uses they are asking. Plane mirror. What are the uses of plane mirror? They are used as a looking glass. Looking glass. They are used in construction of periscope and kaleidoscope. They are also used in solar cookers. They are also used in solar cookers. Okay, so what are the properties of the image formed by the plane mirror? What are the properties of the image formed by the plane mirror? This is also very important question. So the image formed by the plane mirror is virtual, erect and same size. And magnification, very important. Magnification. I am talking about magnification. Magnification is +1 only in plane mirror only will get. So magnification is +1. Magnification is +1 only in the plane mirror only will get it. Only in the plane mirror only will get it, because so height of the image is equal to height of the object. Height of the image is equal to height of the object, and also the image will be virtual, erect and same size. Virtual, erect and same size. The image is virtual, erect and same size of image will form. So virtual, erect and same size of image will form. That's why only in the plane mirror magnification is +1. In the plane mirror magnification is +1. Okay, so I hope it is very clear to you all. Next, so next one we are going to the next question. Okay, so perpendicular means both are if two lines makes the angle between two mirrors is 90 degrees, then these two plane mirrors are perpendicular to each other, makes 90 degrees. So the magnification produced by plane mirror is +1. What does it mean? So if it is plane mirror is +1, they mentioned. As I said, here height of the image is equal to height of the object, and also it forms virtual, erect and same size. So what are the parallax and the marginal rays? So this I will explain with the help of concave mirror and convex mirror, the spherical mirror. Spherical mirrors. So I'll explain. So with the help of spherical mirrors. So spherical mirrors, concave mirror and convex mirror, I'm taking. Okay. So now we will go and discuss about we'll we'll discuss about spherical mirrors. We'll discuss about spherical mirrors now. We'll see. So here I'm considering spherical mirror. So I'm taking this sphere. Ah, perfect. We'll try perfect circle. So I'll try perfect circle. We'll see. So everybody, so observe. We'll see perfect circle will get or not. Very close. Very close. Okay, fine. So we'll see one more. I'll try once again. Circle. So we'll see. Shall we? Are you ready for the victim? I'll try almost. I did. I hope maybe somewhat very close. I hope. That's okay, fine. So adjust because we no time. So I tried my level best. I did Aho, I hope. 98% I hope. Okay, 98% I did. Okay, done. So now you are saying this small curvature I'm considering small curvature. Small curvature I'm taking like this. Okay, small curvature. So it is the depends on the reflection. Depends on the reflection. Okay, so depending on the reflection, so mirrors are divided into two types. So if you are taking like this, okay, so I'm considering the one side is coated, another side is reflecting surface. So if the light ray incident on it, like this, I'm considering. So these are the incident light rays like this. Okay, so this is a concave mirror. Reflection takes place inward. Reflection takes place inward. Reflection takes place inward. That is called concave mirror. Because this is also known as converging mirror. Concave mirror is also known as converging mirror. So why you are saying, sir, concave mirror is called converging mirror? Concave mirror, converging mirror. So 2 minutes break. I'll drink water. Because so 8:17 I'll start 8:17 p.m. Explanation at the rate of continuously I'm talking, just 2 minutes break, 1 minute only. I'll drink some water. Oh. Okay, so welcome to the class again. Now you can see in this case, so concave mirror is also known as converging mirror. Concave mirror is also known as converging mirror. So why we are considering converging mirror? Why concave mirror is called converging mirror? Whenever the light ray incident on it, whenever the light rays are incident on it, so what happen if the light ray incident on it will be converging, or light rays are moving towards the principal axis. Light rays are moving towards the principal axis. Light rays are moving towards the principal axis. Okay, so after reflection, if the light rays are moving towards the principal axis, so the type of reflection is called converging. Actually, this type of mirror is called converging mirror. Best example, so from college or school, you are going to from home to you're going to college, means from different places. So you're converging, so you're moving to college, so like that. So here also, after reflection those light rays are meeting at one point on the principal axis. So after reflection those light rays are converging. That's why it is also called converging mirror. That's why it is also called converging mirror. Whereas convex mirror, you see, this is the concave mirror. Convex mirror, if you take convex mirror like this, I'm considering here. Okay, so this is the pole. Sorry, so actually those terms we'll discuss, terms related to spherical mirror. So after reflection, so I'm taking reflection. After reflection, those light rays are moving away from the principal axis. The light rays are moving away from the principal axis like this. So here, after incidenting, the light rays are moving away from the principal axis. This is the middle one, principal axis. So the light rays are moving away from the principal axis. In this case, light rays are moving towards the principal axis. Light rays are moving towards the principal axis. In this case, light rays are moving away from the principal axis. Light rays are moving away from the principal axis. Light rays are moving away from the principal axis. If the light rays here, if the light rays are incidenting on it after reflection, the light rays are meeting at one point. If the light rays are incidenting on it after reflection, so those light rays are moving towards the principal axis, moving towards the principal axis, moving towards the principal axis, okay, moving towards the principal axis. So that's why it is converging. Whereas here, so after reflection, those light rays are moving away from the principal axis. Those light rays are moving away from the principal axis. So this convex mirror is also known as convex mirror. Convex mirror is also known as diverging mirror. Convex mirror is also known as diverging mirror. Convex mirror is also known as diverging mirror. Concave mirror is also known as converging mirror. Convex mirror is also known as diverging mirror. So what is the difference? Why we are telling converging or diverging, converging or diverging, converging or diverging? Because whenever the light rays are incident on it, after reflection, those light rays are moving towards the principal axis, that's why it is called a converging mirror. So whereas after reflection, light rays are moving away from the principal axis. Those light rays are moving away from the principal axis, Those are it. So that's why it is called diverging mirror. Converging mirror, diverging mirror. The nature of concave mirror is converging in nature. Nature of convex mirror is diverging in nature. I hope it is very clear to you all. Next one, we are going to the rare terms related to spherical mirror. Terms related to spherical mirror, right? Terms related to spherical mirror we'll discuss. Okay. Okay, so now you can see, now you can consider, now I am taking the concave mirror. Okay, so here I am considering the concave mirror like this. Okay. So here this is a part of the sphere. Okay, this is a part of the sphere. This is the center of the sphere. Okay, center of the imaginary sphere. Actually, so the center of the imaginary sphere, in which mirror is a part. C is the center of the imaginary sphere. In which mirror is a part. That is called center of curvature. Second one, midpoint of the mirror is called pole. So the center of the imaginary sphere in which mirror is a part. Is called center of curvature. Here you can see the center of the imaginary sphere in which mirror is a part. Mirror is a part of this one. That's why it is called center of curvature. Pole is the midpoint of the mirror. The line joining of center of curvature and pole is called. So principal axis. Line joining of center curvature and pole is called principal axis. So this is the principal axis I am taking here. This is a principal axis. Okay. So the line joining of center curvature and pole is called principal axis. Principal axis. Center of the imaginary sphere in which mirror is a part. So midpoint of the mirror is called pole. Center of the imaginary sphere in which mirror is a part. Center of the imaginary sphere in which mirror is a part. Midpoint of the mirror is called pole. Center of the imaginary sphere in which mirror is a part. Center of the imaginary sphere in which mirror is a part is called center of curvature. So and one more thing, we can take the midpoint of the mirror is called pole. The line joining of center curvature and pole is called the line joining of center curvature and pole is called principal axis, and the distance between center curvature to pole is called radius of curvature. The distance between center curvature to pole is called radius of curvature. The distance between center curvature to pole is called radius of curvature. The distance between center curvature to pole is called radius of curvature. After reflection, all light rays will meet at one point on the principal axis. After reflection, all light rays will meet at one point on the principal axis. So that is called focus. After reflection, all light rays will meet at one point on the principal axis. After reflection, all light rays will meet at one point on the principal axis. After reflection, all light rays will meet at one point on the principal axis. After reflection, all light rays meet at one point on the principal axis. That is called focus. That is called focus. Fourth one is focus. I'm taking the focus. So focus. And coming to the fifth one, so the distance between focus to pole is called. The distance between focus to pole is called. The distance between focus to pole is called. So the distance between this one focus to pole is called focal length. The distance between focus to pole is called focal length. So denoted with a small letter F. So actually it is a capital F. So focus is capital F. Denoted with the capital F. So that is F I am taking. So small f is the focal length. So here focus here focal length. Okay, denoted with the letter small f. Here a capital F. So focus or pencil focus. Sixth one. Here actually I am taking the concave mirror. Where reflection takes place. Here concave mirror, convex mirror also terms are same. Nomenclature are same. Terms related to spherical mirror, nomenclature to spherical mirror. Anyway, same we are talking. So now, okay. So this, what are the points we are discussing? Those will be applicable for concave mirror and at the same time convex mirror also. So what are the terms we are discussing? Those terms are applicable. What are we are discussing? Those terms are applicable for concave mirror as well as convex mirror. Too. Okay. So here I am taking the distance between focus to pole. The distance between focus to pole is called focal length. The distance between focus to pole is called focal length. The center of the imaginary sphere in which mirror is a part is called center of curvature. The midpoint of the mirror is called pole. The midpoint of the mirror is called pole. The midpoint of the mirror is called pole. The line joining of center curvature and pole is called. The line joining of center curvature and pole is called principal axis. The line joining of center curvature and pole is called principal axis. So after reflection, all light rays will meet at one point on the principal axis. After reflection, all light rays will meet at one point on the principal axis. That is called focus. So that is also called a principal focus. Generally, it is called principal focus. Simple way, so easy way to pronounce. We are using focus. Simple term is focus. Okay. So the distance between focus to pole is called focal length. The distance between focus to pole is called focal length. The distance between focus to pole is called focal length. The distance between focus to pole is called focal length. Distance between focus to pole is called focal length. And one more thing, so width of the mirror. So the reflecting surface is called aperture. So what are the diameter of the reflecting surface? Reflecting surface is called aperture. So aperture. Okay, so aperture you are taking. Aperture. Okay, so the width of the mirror, diameter of the reflecting surface is called aperture. Once again, center of the radius of curvature. Radius is curvature is capital R. So these are the terms, seven terms related to spherical mirror. So terms related to spherical mirror. These are the 7 terms. Once again, we will discuss all those terms once here. So I'm taking the center of the imaginary sphere in which mirror is a part. Center of the imaginary sphere in which mirror is a part is called center of curvature. Center of curvature. And one more we are taking. Pole is the midpoint of the mirror is called pole. So the line joining of center of curvature and pole is called principal axis. Line joining of center of curvature and pole is called principal axis. So after reflection, all light rays will meet at one point on the principal axis. After reflection, all light rays will meet at one point on the principal axis called principal focus. After reflection, all light rays will meet at one point on the principal axis, that is called focus. So the distance between focus to pole is called focal length. The distance between focus to pole is called focal length. The distance between focus to pole is called focal length. The distance between focus to pole is called focal length. The width of the mirror is called aperture. Width of the mirror is called aperture. Width of the mirror is called aperture. And one more thing, the distance between central curvature to pole is called radius of curvature. The distance between central curvature to pole is called radius of curvature. The distance between central curvature to pole is called radius of curvature. The distance between central curvature to pole is called the distance between central curvature to pole is called radius of curvature. The distance between central curvature to pole is called radius of curvature. So these are the 7 points. 7 points. See, these points, whatever we are discussing, these 7 points will be held. So will be used in concave mirror and convex mirror also. This, what are the terms we are using, what are the terms we are mentioning, what are the terms we are representing. So terms related to spherical mirror are nomenclature. Not only terms, nomenclature also we can say. Nomenclature are names. What are the terms we are using? We are using concave mirror. Terms related to spherical mirror. Okay. So those are central curvature, pole, principal axis, focus, focal length, aperture, and radius of curvature. Next one we will discuss about ray rules. We will discuss about ray rules. The ray rules of concave mirror and convex mirror. Ray rules of convex mirror and concave mirror. Now we will discuss. Okay, so okay, just water break. Next one related to terms related to spherical mirror. I will explain terms related to spherical mirror. Okay, fine. So terms related to normally terms related to spherical mirror completed. Terms related to spherical mirror. So now we'll discuss about ray rules of concave mirror. Ray rules of concave mirror. Ray rules of concave mirror. Concave mirror. So now I'm considering here. So first one is so we'll take concave mirror and convex mirror at a time. Concave mirror and convex mirror both at a time we'll take. concave mirror and convex mirror both at a time. So one side is concave mirror I will draw, another side is convex mirror I will draw. So here see, this side is concave mirror, concave and concave mirror, and this side is convex mirror, convex mirror. So first one, I am taking the concave mirror like this. So if the light ray is coming from infinity, if the light ray is coming from infinity, after refraction, first one, if the light ray is coming from infinity, so this is the pole, focus, center of curvature. Light ray is coming from infinity, after refraction passes through focus. So first one, coming to the second one, if the light ray is coming from infinity, light ray is pole, focus, center of curvature. If the light ray passing through focus, after refraction it passes towards infinity. So third one I am taking here. Third one I am considering here. So this is the pole, focus, center of curvature. If the light ray passing through center of curvature, so it retraces its original path. It light rays it moves in the same direction. Coming to the fourth one I am taking. If the light ray incident at the pole, so here is a pole, focus, center of curvature, pole, focus and center of curvature. If the light ray incident at the pole, it reflect back. So it reflect back into the same direction like this. So these are the four ray rules. First one, if the light ray is coming from infinity, if the light ray is coming from infinity after reflection, so here you can see light ray is coming from infinity. Okay, light ray is coming from infinity, after reflection passes through the focus. After reflection passes through the focus. After reflection, so here we see light ray is coming from infinity, after reflection passes through the focus. If the light ray is passing through the focus, after reflection moves towards infinity. If the light ray is passing through center of curvature, it returns its original path. Okay, so if it is light ray is incidenting at the pole, it will reflect back. Coming to the convex mirror, convex mirror I am considering. First one, convex mirror. Convex mirror if you are taking, okay. Convex mirror, convex mirror, convex mirror, convex mirror, convex mirror, convex mirror. So light ray is coming from infinity. Light ray is coming from infinity. After reflection, light ray is coming from infinity. After reflection passes so to so it diverges, it moves away from it. Second one is if the light ray is passing through the center of curvature. So here I am taking. So pole, focus, center of curvature. If the light ray is passing through the focus, so I am considering here one more. If the light ray is passing through the focus, okay, so here. So after reflection passes towards infinity. Coming to the third one, if the light ray is retrace its original path, so I'm taking here, so I'm considering here like this. So here, pole, focus, center of curvature. If the light ray is incidenting at the pole, so at the center of curvature, so here you can consider here. Okay, so I'm taking here like this. So if the light ray incidenting at the center of curvature, it moves in the same direction. Coming to the fourth one, if the light ray incident at the pole, it reflect back. If the light ray incident at the pole like this, so it reflect back into the same medium. Okay. So first one, if the light is incidenting at the mirror, it reflects back, it passes through the focus. Second one, if it is passing through the focus after reflection, passes towards infinity. So if it is passing through the central curvature, it retraces its original path, And here, if the light is incident the pole, it reflects back. So for convex mirror also same scenario. So convex mirror also same points will take. If the light ray incident, at the mirror, so if it is incidenting on the mirror, it reflect back. So it reflect back. So if you are extending that reflector light ray passes through the focus. Reflector light ray passes through the focus. So coming to the second one, so it passes through the focus after reflection passes towards infinity. And coming to the third one, light ray passes through center of curvature. So okay, so it reflect back into the same path. So coming to the fourth one, if the light ray incident at the pole, it reflect back. If the light ray incident at the pole, it reflect back. Okay. So I hope it is very clear to you all. So this is about ray rules, and coming to the next one, image formations. We'll discuss about image formation. Now you can go for image formations of concave mirror. Right? So again 9 o'clock you'll be having class. So I'll be taking break. So 10 minutes or 20 minutes. I'll let you know. So after completion of this concave mirror, so 9 o'clock again 9 o'clock or so I'll let you know according to the explanation of concave mirror. So we'll discuss about the timings. So again we'll be having refraction topic I'll discuss. Still we didn't discuss about reflection completely. Still reflection chapter is there. Okay, so still few more points are there. Nearly half an hour time it will take related to concave mirror and so image formations of concave mirror. Concave mirror image formations we'll discuss now. Concave mirror image formations. First one I'm taking here. So concave mirror I'm considering here. This is a concave mirror. So pole, focus, center of curvature. How many light rays are required to form the image of the object? Minimum 2 light rays. Minimum 2 light rays are required to form the image of the object. Minimum 2 light rays are required to form the image of the object. Okay. So object is at infinity. Image will form at focus. Object is at infinity. Image will form at focus. So how many light rays I'm taking? 2 light rays. 1 light ray I'm taking here. One more light ray I'm considering here. So after reflection, so those light rays will meet at focus. Okay, so I'm considering here. Okay, so this is about reflector light ray, incident ray, reflector light ray. Object is at infinity, image will form at focus. Nature of the image is real and inverted, and size of the image is highly diminished. Highly diminished image will form at focus. Once again, so concave mirror I am taking, concave mirror. So light rays are coming from infinity. Okay, light rays are coming from infinity. After reflection, those light rays will meet at focus. So what type of image will form? Real and inverted and highly diminished. Second, coming to the second one. So if you are taking the concave mirror here, so ray rules of image formations of concave mirror we are discussing now. So this is a concave mirror. So this is a pole, focus, center of curvature, pole, focus and center of curvature. Object is placed beyond center of curvature. Object is placed here. So I am taking here. Object is placed beyond center of curvature. So how many light rays? Minimum 2 light rays I said. So one light ray I am taking like this, one light I am taking like this. After reflection, it passes through the focus. So one more light ray passes through the center of curvature like this. Okay. So here. So the image will form between C and F. The image will form between C and F. So image will be forming here like this. Object is placed. Object is placed beyond center of curvature, beyond C, beyond C. Image will form beyond C, beyond C, beyond C. Image will form. Object is formed beyond C. So here, image will form between C and F. Image will form between C and F. C and F. C and F. So nature of the image is real and inverted, and size of the image is nature of the image. So here you can consider object is placed beyond center of curvature. Image will form between C and F. Image will form between C and F. Nature of the image is real and inverted. Nature of the image is real and inverted. Coming to the size of the image is diminished. Size of the image is diminished. Diminished. Okay, so coming to the next one. The next one I'm taking. So I'm taking here. This is the pole, focus, center of curvature. So object is placed at center of curvature in this case. Object is placed at center of curvature. So I'm taking here. So how many light rays I said? Minimum 2 light rays are required to form the image of the object. Minimum 2 light rays are required. So one light ray I'm taking like this. So it passes through the focus. Passes through focus. Focus. So image also you can take. Better you can take image. So this is another method to draw the. So I'm taking image also. So pole. Okay. So like this we can take. So object I'm taking here. Object. Object at C. Object at C is also will form at C. Object at C, image also will form at C. Object at C, image also will form at C. Nature of the image is real and inverted. Real and inverted. Size of the image is same size. Size of the image is same size. Okay. So object is placed at C. Image also will form at C. Object is placed at C. Image also will form at C. Nature of the image is real and inverted, same size. Real and inverted and same size. Object is placed at object is placed at C. Image also will form at C. Nature of the image is real and inverted and same size. Coming to the this is the third. Coming to the fourth one. Pole, focus, center of curvature. In this case, object is placed between C and F. Object is placed between C and F. Okay, so object is placed between C and F like here. One light I am taking like this, so it passes through the focus. Another light I am taking here, so incidentting at the pole. Those will be emitting like here. So image will form here. Object is placed. Hi Tanishka, how are you? Welcome to the class. Good evening, sir. Good evening. Please listen to the class. Notion, hi. And Subham, okay. Okay, so welcome to the class. So now we can go to the next one. Now we can go to the next one. Next one is object is placed. What are the chapters? Physics chapters. So B point is okay. Okay, done. We'll work out. So now you can see object is placed between C and F. Object is placed between C and F. Object is placed between C and F. Image will form between so image will is forming beyond C. Image is forming beyond C. Nature of the image is real and inverted. Nature of the image is real and inverted. And coming to the size of the image is enlarged. 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 So that is the fourth one. Coming to the fifth one. Fifth one. So I am taking this the pole, focus, center of curvature. Object is placed at F. Object is placed at F. So I am taking object is placed at F. Object is placed at F. One light I am taking like this, passes through focus. Another light incidenting at the pole, it reflects back. So object is at F. Image will form at infinity. Nature of the image is real and inverted. Size of the image is highly enlarged. Size of the image is highly enlarged. Coming to the sixth one. Sixth one is very, very important for 3 marks question. This chapter, for 3 marks question, this question will come for 3 marks. 3 marks, this question will come very, very important. Make sure that you are practicing here. So I am taking like this. So this is the pole, focus, center of curvature, pole, focus and center of curvature. So okay, notion. So it's okay, fine. So it will happen. We can do our work. Okay. Thank you so much for supporting and taking stand. So here you can consider object is placed between F and P. Object is placed between F and P. Okay. So one light I am taking like this. So one light I am taking like this. One light I am taking like this. So how many light rays are required? I said 2 light rays. One light I am taking like this. It passes through the focus. Another light ray is passing and incidenting at the pole. Incidenting at the pole here. So incidenting at the pole. So it reflect back. Okay. So if you are extending this light rays, so okay, done. Now I'm taking, if you are extending this light rays, okay. So I'm extending this light rays. If you are extending this light rays, the light rays will meet behind the mirror. Object is placed between F and P. Object is placed between F and P. So image will form behind the mirror. Image will form behind the mirror. Object is placed between F and P. Image will form behind the mirror. Nature of the image. Object is placed between F and P. Nature of the image is virtual erect. Image is behind the mirror. Behind the mirror. Image is behind the mirror. Behind the mirror. So nature of the mirror is virtual erect and enlarged. So here you can see only this last case, only concave mirror forms virtual erect enlarged. So virtual erect and enlarged, only concave mirror forms virtual erect and enlarged image. Coming to the convex mirror, virtual erect and diminished. Coming to the plane mirror also same thing. Plane mirror also same thing. Virtual erect and same size. Virtual erect and same size in plane mirror. Virtual erect and same size in the plane mirror. Virtual erect and enlarged in concave mirror. Okay, so thank you so much for your support and joining and listening and okay, so keep supporting me. Definitely I will do great content. So definitely, so it will be helpful to you. So you can do well in your exams. You can learn better. Okay, so I will do my level best to teach in a best possible way. So thank you so much for everyone. Please keep supporting me. So keep encouraging me. Definitely, I will do the content in a best possible way. Definitely, that will be helpful. Okay, helpful. You can learn the content. You can prepare well. Okay, so if you have any doubts, you can ask me. So those you need, if you need any regarding any content or any doubts you have, if you have any doubts, any explanation is required for particular topic. So if you are not getting particular topic, or if you want help in exams, so when exams are coming, so you need any explanation of the topic. If you need like that, so any explanation of content, any chapter, anything. So not only one subject, remaining subjects also. So maths, chemistry, biology, social, English, from right from 6 to 12, so if you need any subject, like classes, if you want, you can contact to this number 9849812804. So this is the contact number. You can contact to this number 9849812804. If you contact to this number, okay, so my team is there. I had a great team. Nearly 5 to 10 years experience faculty members are there in my team. So you can contact. So you can get the classes. Okay, you can try to reach to me through that number. So WhatsApp number only. So you can contact to me through that number. Okay. So this is about Siva sir from Student the Brand. 9:30 I'll be taking class again from 9:30 onwards. Join at 9:30. 9:30 again I will take class. 9:30. 9:30 again I will take class. So thank you so much for your support. Okay, join to the class, learn the subject in the best possible way. We'll discuss. So now 9:30 I'll start again. 9:30 I'll start. So live class. So please join and so we will discuss the light chapter. We'll continue until here we discuss. Still we will continue the concept. So thank you so much for joining. So please do like, share, and subscribe to Student the Brand. If you like this content, please do like, share, and subscribe to Student the Brand. Thank you so much.